All right, this is 7.1, classify angles. This should be a pretty quick lesson because this is stuff that I believe has already been covered in grade school. So classify means what group it fits into. So if we're talking about classifying an angle, that's a little bit different than naming an angle. We're going to be able to name an angle after this lesson as well. But to classify means we want to group it in one of these several groups. We have acute angles, and acute angles are angles that measure less than 90 degrees. So one thing that we need to know is what a 90-degree angle looks like, because that's going to be kind of our benchmark. Well, a 90-degree angle is a right angle. So the next one that we're going to use to define a right angle is exactly 90 degrees. And they're angles that you see all over in the real world. If you look at the floor and each wall, they should be at a 90-degree angle. Okay, the corners of squares that we use everywhere are right angles, these 90-degree angles. So anything that's less than that right angle is a 90-degree angle. And so you can notice that this is less than 90. If I were to draw a 90-degree angle, it would be like the floor and wall. Less than that is 90 degrees. This is an acute angle. This one up here is an acute angle. The outside one, if I could highlight that in a different color here, this would be now a right angle. We have an acute angle and an acute angle that add up to be that right angle. If we go on to the next classification, it is an obtuse angle. An obtuse angle measures greater than 90 degrees and less than 180 degrees. That's part of the definition as well. But that means if we go back to our benchmark of 90 degrees, there would be a 90-degree angle. They put that little square in the corner of it so you know it's a right angle. And this is larger than that 90-degree angle because it goes from this one out to this one. That's more than 90, so we have what is called an obtuse angle. The last major classification is straight angle. And a straight angle measures exactly 180 degrees. And we might just think about it as a line, because that would be a line if I just looked at it that way. But you can also think about it as an angle that measures 180 degrees, and that would be a 90 plus a 90. If you think about it that way, a 90 plus a 90 equals 180 degrees. So from small to large, they kind of help you remember it because it's almost, it misspells it, but you can misread that as the word arrows, which is kind of what these angles are made up of, is arrows. So you can start with a less than 90, you work up to a 90, so we start with acute and then right. We work up to greater than 90, which is obtuse, and then we go to straight, which is exactly 180 degrees. So we want to be able to name angles and classify angles. So what we were just working on was classifying angles. So let's classify this angle first of all. Is it 90? Is it less than 90? Is it greater than 90? Or is it 180? If you look at it and compared it to what a 90-degree angle would look like, it is less than 90, so we would classify that as an acute angle. It's less than 90 as far as its angle measurement. Okay? Now, we want to be able to name it. To be able to name it, we need to know what the vertex is. The vertex is the most important part. It's where the two lines or rays or line segments meet. And so the vertex would be the point M. Okay? So I want to identify that because that's the most important part of this. It's where they meet or intersect. You might notice that this ray MK is intersecting with this ray MH at the point M. Okay, so that is our vertex. If I want to name this angle, you can name it several different ways, but you're always going to put an angle sign, which looks like this, in front of the name of it. So I could call this just by its vertex, angle M. Now you can do this as long as it's the only angle that is made with that vertex. So this one only has that angle that comes out of that vertex M. So you can also name it by the three letters that go to it. So you might say, well, K and M and H are all on that angle, and the most important one is M, so it has to be the middle one. So if you're writing it with all three, the vertex has to be the center. So you call it angle KMH. You could also call it angle HMK. But you couldn't put it in any other order than with M in the middle. The vertex is the most important point. And a lot of times they'll put something inside it. Notice this is not a degree measurement. They're not telling you it's 7 degrees. They're saying you can call this angle 7. So we can classify it as acute. We can name it by its vertex or by its 3 letters, but with the vertex in the middle, or some way that it's been defined like that number 7. So here's an example that I want to use to show you why you can't just say, okay, well, the vertex is H, which I agree, the vertex is H, but you can't just name it by angle H. Because if I said now angle H, do you see how you would have a problem identifying that? Angle H could be this angle, because that has the vertex of H. It could be this angle, which has the vertex of H, or it could be this angle, which has the vertex of H. So if you see it now, there's 3 possible things that have a vertex of H. So we're not going to be able to call an angle just angle H any longer. We're going to have to be more specific. So name that blue angle for me. Think about how you would name that blue angle. You could call that angle FHG or angle GHF. Okay? If I said name the green angle, well, the green angle would be angle GHJ or angle JHG. And if I said, well, give me the red angle, well, the red angle is angle FHJ or angle JHF. So that's the way we would name those. Let's classify them real quickly. Classify the blue one. It is less than 90 degrees, so that blue one is called acute. Classify the green one. The green one is greater than 90 degrees. You can call that obtuse. If I say classify the red one, that is exactly 180 degrees. That would be a straight angle. All right, now we need to be able to talk about a couple of special relationships with angles. So a couple different relationships that we're going to talk about are vertical and adjacent. Vertical angles are angles that are opposite each other, and they're formed by the intersection of 2 lines, and vertical angles are always congruent. They're going to share the same vertex. Okay, so if I look at angle 2, let me highlight angle 2 here. Angle 2 has the same vertex as all of those other angles, right? They all share a common vertex. But if you were to trace this green line all the way through and this green line all the way through and make it just 2 intersecting lines or rays or segments, you see that angle 2 is directly across from angle 6. Angle 2 and angle 6 are what we call vertical angles. And here's one thing that we need to know. Vertical angles are always congruent, which means they have the exact same measure. And I don't like my drawing there. I'll try it again. The symbol for congruent looks like a wave above an equal sign. And that lets me know that they have the exact same measure. So let's say angle 2 is 34 degrees. If I told you that angle 2 is 34 degrees, then one thing you could tell me is angle 6 also has to be 34 degrees. Has to be, because vertical angles are congruent. Okay? So let's practice on that. What angle is congruent to angle 1? Well, if you drew angle 1 and continued it on through, there's the ones that make up angle 1, and directly across from angle 1 is angle 4. I kind of covered it up, but angle 1 and angle 4 are vertical angles which are congruent. What angle is vertical to angle 3? Well, remember, if we traced them on through, 3 would be opposite of 5. So angle 3 and angle 5 are vertical angles, which makes them congruent. One common error is for people to look at like maybe angle 6 and angle 3 and say that they're across from each other. But remember, angle 6 is across from angle 2. They're the ones that if they use those intersecting line segments or rays, they're the ones that point at each other, 6 and 2. Okay, so be careful and make sure that they are directly across from each other. Another angle relationship that we need to look at is adjacent. Adjacent means right next door. What that really means is they share a common vertex and a common side. In other words, they're touching each other. So if I went back to angle 1, here's angle 1. It shares the common vertex with all of those, but it only shares a common side with 2 of these. It is right next door to angle 2 because they share this common side right here. It is also adjacent to angle 5 because they share this common side right here. So if I said angle 1 is adjacent right next door to, there are two possibilities here. Angle 1 is adjacent to angle 2, and angle 1 is adjacent to angle 5. Now this doesn't tell you that they're congruent. We don't know that. There are special times when they will do something special, which will be next lesson. Like if that's a right angle, if I had these two acute angles that add up to a right angle, that's called complementary. Angle 1 and angle 2 in this case are complementary because they add up to 180. And a lot of times if you just have a straight angle, right, and there might be an intersection or something like that, then you have these two angles, this one and this one. One's obtuse, one's acute, and they add up to this green angle, which is a straight angle, so they would add up to 180. So remember, these are called complementary, these are called supplementary. So you might be able to tell something special, but not always, because like angle 1 and angle 2 don't add up to 90, they don't add up to 180, they don't add up to anything special. So we just know they're adjacent, we just know the relationship. So let's practice that. What angle or angles are adjacent to angle 6? Hopefully you answered angle 5 because they share that common side and that common vertex. And hopefully you answered angle 4 because they share that common side. So 4 is right next to 6 and 5 is right next to 6. What angle is adjacent to angle 3? Well, 3 has this is 3, and this is 3, and this one is shared with angle 2, so angle 2 is adjacent, and this one over here is shared with angle 4, so angle 2 and angle 4 are both adjacent right next door to angle 3. So now let's practice using that knowledge that we just gained. So if I had this first problem, and it said 6g plus 24 degrees and 144 degrees, I need to know the special relationship. Those two are directly across from each other, which is called vertical. They're vertical angles, and that tells me they're congruent. That tells me that 6g plus 24 has to be equal to 144, and now we would just be into an algebraic equation where I would say, well, let me subtract that 24 from both sides to cancel it out. That gets me 120 equals 6g. Let me divide by 6 to cancel out, and you're left with g equals 20. So now we can know that g equals 20 in that application. But that's based on the fact that we know that those two have a special relationship called vertical, and that makes them congruent, which gives us enough information to then write this algebraic equation to solve. In the second problem, I have a little bit of a different relationship. I don't have angles that are across from each other, vertical angles. I have two angles that are right next door to each other. This angle, this green angle, is adjacent to this red angle, and they add up. If you look at it, they add up to that blue angle, and I know the measure of that blue angle because that's a straight angle is 180. So that means that I could write this, that 7y plus 6 plus an extra 83 has to equal 180. And we would be into now an algebraic equation that we could solve. So I'd get my like terms together. So I would have 7y plus 89 equals 180. I'd be in a two-step equation. I'll do this one with rainbow. There was a y that they multiplied by 7 and added 89 to get to 180. So you would subtract 89 and divide by 7 and make sure you hit equals in between. So 180 minus 89 is 91, and 91 divided by 7 is 13, so y must equal 13. Again, we had to know the relationship and that idea of supplementary to be able to solve that.